Hi and welcome back. So in the past video we went over our SI standard units prefix multipliers, and again I'm making this video more so you can make your own reference table that you'll be able to refer back to, because we are going to use these prefixes at different points in the playlist, and I guess more importantly, when you take the chemistry course, you'll definitely see these prefixes pop up. So it's to your best advantage to maybe write these down in some spot where you can refer back to them when you need to. So anyway, in the last video, we dealt with pretty much all the prefixes that are going to be larger than, I guess, our base unit. And we said, we could have meters, we could have grams, we could have seconds. One of the things I talked about a lot in the past video is we could have bytes, although the bytes, and maybe I'll do this maybe in a different playlist probably, but bytes aren't, they're not exactly 1,000. A kilobyte is actually, I think, 1,024 bytes, so it's not, you wouldn't exactly have 1,000 bytes in a kilobyte, and maybe we'll go into why in a future playlist, but anyway, if we have a kilometer, that means we have exactly 1,000 meters in a kilometer. But anyway, so for this video, we're going to talk about the standard units prefix multipliers for when we're dealing with units smaller than whatever the base unit is. So if we said that we had this is the first one. If we had a and we could say maybe it's a decigram or a decimeter or a decisecond, then we would have our symbol would be D. So if we had a decigram, we would have DG. If we had a decimeter, it would be DM. And what this is it's pretty much 1/10. It's 1/10 of whatever the unit is. So it would be 1 decigram would be 1/10 of a gram. And it would be 0.1 of a gram. And so this means, what's 0.1 if we were going to write that in scientific notation? Well, it's 10 to the minus 1 power, right? So if we said that, I had 2.3, if I said I had 2.30 decigrams, and I wanted to just write this in scientific notation without using decigrams, I could just say that this is 2.30 times 10 to the minus 1 grams. So that's what these prefix multipliers help us do. It's more or less a way in English to say what our unit would be if we wrote it in scientific notation. So that's what we're really trying to do with these prefix multipliers. So anyway, this is the first one, deci. The next one, and maybe you've heard this before, but centi. So if you have a centimeter, you probably know the centimeter. You would write as cm. If you have maybe a centigram, which maybe you probably haven't heard of, that would be cg. You would have our symbol for this is going to be, it's actually a lowercase c. That might look too much like an uppercase C. Let me just erase that and write, so lowercase c, if that makes any difference. And then this would be, it would be 1/100th of whatever we had. So there are 100 centimeters in 1 meter. And so what is our scientific notation? What power of 10 is this going to be? Well, it's going to be 10 to the minus 2, right? So if we had 25 centimeters, that's the same thing as saying we had 25 times 10 to the minus 2 meters. So anyway, I think hopefully you're getting the hang of this now. So anyway, our next one of these, so we've got centi. The next one is going to be the milli. Milli. And probably you've heard of milligrams or millimeters. So, and you can imagine that if you have milligrams, you have mg. If you have millimeters, you have mm. So our symbol for this is just going to be a lowercase m. And we are going to have, for every meter, we have got 1,000 millimeters in a meter. So that means that we have 1 millimeter, or 1 milli something, is going to be 1/1000th of whatever that something is. So our scientific notation is going to be 10 to the minus 3. And hopefully, I'll do one more of these examples. I think you're probably getting the point of this. But if we had, this is something we'll probably be dealing with a lot in the chemistry playlist. Say we had 450 milliliters. So this is a unit of volume. Our regular unit for volume would be the liter. So say we had 450 milliliters. That means we have 1,000 liters in every. We have 1,000 milliliters in every liter. So if we wanted to write this in scientific notation, we could say that this is 450 times 10 to the minus 3 liters. So that's what this means. That should be a 5 there. So anyway, that's one more example. I guess probably I think you're getting the hang of this. I'll just start going through these. Next we have the micro, and this symbol, it's actually a Greek symbol. I think this is the symbol mu in Greek, and that's what we use to represent micro. And we will definitely start dealing with micrometers, particularly when we start dealing with wavelengths of light and different really small units of particularly distance. We'll start dealing with micro, and micro is going to be. It's going to be, I think, is it 1/millionth? Yeah, it's 1/millionth. 1, 2, 3, 4, 5. So this is going to be 1 raised to the 1, 2, 3, 4, 5, 6. So our scientific notation would be 10 to the minus 6 for 1 micro something. If we had a micrometer, we would have 10 to the minus 6 meters. So next is going to be our nanometer. Maybe you've heard of nanotechnology. And that you can imagine how small this is going to be. This is going to be 1/1 billionth. 1/1 billionth of a meter. So this is 1, 2, 3, 4, 5. Okay, there we go. So I think that should be 1/1 billionth. And this scientific notation is going to be 10 to the minus 9. And you can kind of remember nano and 9. Nano, some of these might be good to memorize a little bit. And nanometers, specifically when we start dealing with wavelengths of light, would be a good one to just remember that nano is going to be minus 9. Now I think I wrote in enough zeros. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, that's right. So next we have got the picometer. And that symbol is going to be P. And the picometer, this is going to be an important measurement when we start talking about atomic radii. Atomic radii are really going to be measured in picometers. And I think, how many more is this? This is going to be 10 to the minus 12. 10 to the minus 12. And so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, that should be right. So there's our picometer. Very important, prefix to know for when we start dealing with atomic radii. Next, we have got the femto. And the symbol is F. This is going to be. I'll write the scientific notation first. This is going to be 10 raised to the minus 15th power. And so you can imagine we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yep, so that would be our femto. And then the last one is the atto. and symbol is A. And this one is incredibly small, you can imagine. It's going to be 10 raised to the minus 18th power. And so this is going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there, that is going to be our atto division for our standard units prefix multipliers. So anyway, maybe in the next video, I'll just do a couple of examples of saying, you know, if we kind of, like I said, where if we have 450 milliliters, how many liters would that be? Maybe I'll do a couple examples like that, and just so you can check and make sure that you've got the hang of this stuff. If you feel like you've got the hang of it and you've got your table of all these different prefixes written down, and you feel like you understand it fine, and you can then you'll just be able to use the table when you need to throughout the playlist and throughout the course, then I'd say you don't necessarily have to bother watching the next video. In the next video, I'll just make a few different examples of this, and if you feel that you need to watch that video and see the examples, then definitely check it out and see if it helps. So anyway, thanks so much for watching, and I'll see you in a future video.